Okay, welcome back everyone to theCUBE's coverage here in San Francisco, California of AWS Summit 2022. I'm John Furrier, host of theCUBE. AWS Summit in New York City is coming up in the summer. We'll be there as well for live interviews there. Events are back, and we're excited to have a great guest here, Ayal Yogev, CEO and co-founder of Anjuna Security, based out of Palo Alto. Great to have you coming on theCUBE, appreciate it.
Yeah, thanks for having me.
So tell us about what you guys are doing. You guys have a really cool concept, confidential computing. Take a minute to explain what the company does.
Sure, so at a high level, confidential computing is the ability to take any workload, any piece of data, regardless of how sensitive it is, and run it completely isolated, completely private, completely protected, essentially on any infrastructure. And that enables organizations to take any workload and move it to potentially sensitive locations like the public cloud where somebody else is managing your infrastructure.
So basically the problem you solve is you provide a security layer for workloads.
Exactly, exactly.
And it's obviously government security issues, but also just general hacking, right?
Oh, exactly. Essentially any organization having any type of sensitive information, think about financial services, think about healthcare, think about oil and gas that need to protect the data of where they're going to drill next. Any kind of organization that has sensitive information has that issue and needs to protect data in any environment they run on.
So Amazon would be like, AWS, wait a minute, we're secure? Well, come on.
Actually, AWS is one of our partners, and we're actually building on top of a new technology that AWS built called Nitro enclaves. And actually, all the public clouds have built a technology like this. The reason why they've done this is security and privacy are the #1 and #2 reasons why people don't move more workloads to the public cloud. Mm-hmm. So what the public clouds have done is added this technology to be able to tell their customers, one is, we don't have any access to your data running on top of our infrastructure, and #2, be able to turn to the government and tell them, do you remember the case with the iPhone and the FBI, where the FBI came to Apple, asked them for data on the iPhone? Yeah. And Apple said, we just can't, we don't have access to that data. This is exactly what the public clouds want to be able to do. Turn to the government and tell them, we just don't have access to our customers' data.
Wow, that's going to put a lot of pressure. So let's talk about the surface area of attacks. How has that changed? What's your role in that? Obviously, there's no perimeter anymore in the cloud, and the perimeter security is dead. That's a huge issue. Yeah,
of course. So I guess where we fit into this, as I mentioned, all the clouds added this technology. Where we fit in is very similar to what VMware did for virtualization, right? Virtualization was this extremely powerful technology that everybody knew was going to change the world. You wouldn't have the public cloud without virtualization. But the problem was it was very difficult to use, very, very low level because it was a hardware technology, and then every vendor built a different technology. This is exactly the case now with confidential computing. Every cloud added a hardware level technology to go support this, but one, it's very low level, it's very, very difficult to use, and every cloud added a different technology, which makes it even harder for organizations to go use. We added a software stack, exactly like VMware did for virtualization, to make it super simple to use and ubiquitous across the different clouds.
How did you come up with the idea? Where did this all come from? Were you scratching an itch in security? Did you have one of those things like, hey, I can solve this problem? What was the origination story? Where did this all start?
Yeah, it's actually, I've been in security for over 20 years now, and I kept running into that same problem, right? I was actually in Unit 8200, which is the Israeli equivalent of the NSA. I was then in the private sector, and I was a bunch of companies, OpenDNS, Cisco, and I kept running into that same issue. And when you kind of peeled the layers of the onion of what the core security problem was, it always came back to how do you protect data while it's being used, which is essentially the same sort of core problem that confidential computing solves. But there was never a solution, there was never a way to solve this. And about 4 years ago, my co-founder just finished his PhD at Stanford, and he ran into, there's finally a way to do this. Finally, the CPU vendors have built something in, the clouds are going to adopt this. This is going to allow you to, one, finally solve that huge problem that always existed, and #2, this allows you to kind of re-architect security the right way. Because this has always been the core problem that people try to somehow mitigate, never having a good solution.
It's like putting a wrapper around it or an envelope and saying it's secure.
Exactly.
So was this PhD work at Stanford in parallel to industry momentum at the same time serendipitously, or was it kind of like, was he working with partners already in his program?
Yeah, so he just, this was something that was happening, and this has been going on for well over a decade. It actually, funny enough, it started with cell phones. I don't know if you ever thought, what happens if you lose your phone? You have the biometric data, right? Your fingerprint or your face ID. Can somebody get that information out of the phone if you lose it? And what the phone vendors have done is basically put in a confidential computing technology to make sure that even if somebody gets physical access to your device, they're not going to be able to get access to that data. And what the evolution was is that the Intel, AMD, the CPU vendors have realized, wait, this is a really, really great idea, we should put it on the server side as well. And that started with Intel in 2015, so this has been an evolution, and now essentially every one of the CPU vendors is now supporting this. You have Intel, and ARM, and AMD, NVIDIA just announced their confidential GPU solution, all the clouds have adopted this. So my co-founder, when he ran into this was as this was starting to happen, he got extremely excited, but he has noticed the big problem of everyone is coming up with different solutions. We're going to need to build a software layer on top of this to make it usable. So you have to get
this to be de facto.
Exactly.
Standard.
Oh.
How's that going? So Amazon's a partner?
Amazon's a partner, AWS, Azure is a partner. We can run on top of essentially any one of the clouds out there.
They're enabling you to do that because they want to buy into security.
Exactly.
They want the benefit.
Exactly. They want to tell their customers, you can move anything to the cloud because we don't have any access to your data. This helps them essentially sell more cloud.
A couple things around, I want to ask about performance, but before I get to that, it seems like this whole protected data thing has always been like a database thing, not so much low level resetting, if you will. It's almost a reset. It's not like just protect your data in the database.
Oh yeah, yes.
This is different.
Yes, exactly. It's funny because you bring sort of the exact right point. When we kind of think about where data can reside, there are essentially three locations. There's data at rest, which is essentially data in a database or a file system. There's data in transit, which is data on the, in the network.
Move,
and then there's data at use. And the data in use piece is essentially when an application needs to process data, it has to decrypt it and load it completely in the clear in memory in order to process it.
Got it.
And at that point, the data is not protected. This is why it's so hard for organizations to move data to the cloud or to run data in geographies where they're not, they don't trust the government or don't trust the admins.
So injecting some malware or vulnerability or attack in the workload while it's running is just another attack vector.
Exactly, or just stealing the data. If you have access to the infrastructure, if you can run code, you can then just basically look in the memory and get all the data out of it. And to some extent, even the encryption keys you use for data at rest, those keys live in the clear in memory. So even that hasn't been completely solved.
Got it.
Now that you have this component, you can finally solve that problem and protect the data regardless of where it resides.
All right, so I got to ask the performance question because remember, going even back to the earlier days of encryption, there's always overhead penalty.
Yes.
But cloud's a beautiful thing. You can spin compute up. And you're talking about now, the CPU vendors are kind of getting involved.
Yes.
Talk about the security, how you mitigate that. Is it an issue, no issue, why?
Yeah, actually, let me talk about performance because I think this is a really, really great point. What's nice about this, and this is why the sort of the benefit of the CPU vendors doing this, performance has always essentially had two underlying issues. One is performance, as you mentioned, and the other one is ease of use. This is sort of the piece we add to, that we make it super simple to use, when you can take essentially any workload and run it securely on top of any one of these solutions. And the performance thing, the heavy lifting is done by the hardware vendors themselves, which means there's another chip next to the CPU that does all the heavy lifting encryption, which is very similar. I don't know if you remember the TLS, or the SSL acceleration cards. This was exactly the same thing. It was this chip outside the CPU, so it's not in the sort of the critical path that does all the heavy lifting. And this is what allowed TLS or HTTPS to become the default way you now protect every website. And this is sort of, when security becomes transparent and there's no performance impact, like why wouldn't you use it for everything? Exactly.
It becomes a no-brainer unless there's legacy baggage.
Right.
In either dogma around use this approach, culture issue, or technical.
Right.
Got to unwind those two things. So what's your take on that? What's your reaction? Culture's easy, just like, I think that's easy to fix. We want better security, get on board, or see you later.
Exactly.
Technical architecture could be an inhibitor. How do you see that? Is it a blocker? How do you unwind that? How do you get that to reset?
So it's exactly the value that we bring to the table. We've built a software stack to make it super simple. You don't need to, you don't need to rewrite the application. You don't need to recompile. It's essentially security becoming a part of the infrastructure. You essentially have security as just a piece of the infrastructure that makes it super simple and again a no-brainer. Exactly the way TLS was. We're a software vendor.
All right, so how do I see it integrating with Amazon. It's going to get into the chip level, they're enabling hooks for you.
Exactly.
That's how it works?
So there's essentially all the cloud vendors have enabled these technologies. For Amazon, it's essentially this hardware capability. We have access to it, and we're a software layer on top of it to make it simple. Similar to, again, what VMware did for virtualization, and what, to some extent, this is what Microsoft has done for the CPUs, what Windows is, right? Every time there's a new, really amazing hardware feature, you need a software stack on top of it to make it simple to use.
You know what's great about the cloud is that you kind of have that whole operating system mindset now being democratized across everything.
Right.
I mean, it's a systems thinking in software
right.
with all the CapEx of the cloud,
yes.
and you're decoupled from it, and you're riding on top of it.
Exactly.
It's an amazing opportunity. As a co-founder, just, if there was no cloud, how hard would this to be to do? I mean, like almost impossible.
Yep.
So, very cool. All right, take a minute to explain what you guys are working on. How big is the company? What you guys are doing right now? You're hiring, you're looking for people, funding. Give a plug for the company.
Sure, so we're a Series B company. Raised 30 million from Insight in the last round. We're about 80 people right now. We're growing extremely aggressively. Mostly on the sales side, on the sales go-to-market side, just because of the demand that we're seeing in the market. But we're also growing on the engineering side. So again, we're always happy to talk to people who are excited about this.
In Palo Alto, but probably have remote teams?
We're based in Palo Alto, so the sort of headquarters and most of the team is in Palo Alto, but yeah, we're very open to remote. We have now engineers all across the US and also outside the US as well, just because COVID made it sort of very easy to do that.
Right, I mean, you got a good product, great idea, and a great opportunity. I mean, this is, you know, Dave Vellante and I at a VMworld, I think it was like 2013. Now we're dating ourselves. This is when we started covering AWS.
Yep. He
asked Pat Gelsinger, it might have been 2015, because the CEO of VMware at the time,
yeah.
Is security a do-over?
Yep.
And he's like, absolutely, and this is now happening. This is a security mulligan, a redo-over. This is what we need, right?
Exactly, and this is why, so we're part of something called the Confidential Computing Consortium, which essentially has all the large, it's all the, the cloud vendors, the CPU vendors, VMware is a part of this as well. Basically, this is sort of too big of a shift for these large organizations to ignore. And yeah, VMware is definitely going to have a part of this.
Awesome, well, congratulations. You guys are going to probably be really huge or get bought out pretty quickly.
I think this is just a huge opportunity. We can become the VMware of security. Yeah. So I think this is, I'm hoping to stay independent.
Yeah, congratulations on a great venture. Love the idea, and again, every application should run this way. It's a no-brainer. If you can get that security built in, yep. You got a shield, right? You wrap it up, plug it anywhere.
Exactly.
May the best cloud win.
Exactly.
Right?
Exactly.
And that's what's going to happen. That's why I love the silicon angle of Amazon silicon play.
Yes.
As that silicon gets better,
yes,
it only helps these kinds of use cases, right?
Exactly, exactly. We leverage these technologies, and to some extent this is actually part of the value we talk to customers about, because this is sort of the cutting edge of technology and security, and this keeps evolving. As I mentioned, NVIDIA just announced their confidential GPUs. We provide this layer on top of it where organizations don't have to go and kind of rebuild every application as this evolves, and just use our technology.
People who know me and theCUBE know I'm a hawk when it comes to cybersecurity. I think the red line is people operating below the red line, and why should companies have to provision their own militia?
Exactly.
Here, this is essentially the shield they can put up,
exactly.
And not to rely on the government, who doesn't know what they're doing.
Exactly, exactly. Security should be easy, should be used everywhere, exactly.
I'm sure you get a lot of banking customers, fintech customers coming on board.
Exactly.
Right out of the gate. Yeah, thanks for coming on theCUBE.
Yeah,
Appreciate
thank you.
Okay, live coverage here, San Francisco, California. I'm John Furrier with theCUBE. We'll be right back with more after this short break.